In this lesson, we're going to look at multiplying and dividing directed numbers. Firstly, we're going to look at the symmetry of the number line. If you imagine a mirror line through 0, you can see that all the positive numbers are reflected through that line to make all the negative numbers. If I multiply a number by 1, it'll stay the same size, as we know from our previous maths, and it will stay on the same side of 0. So if I do 1 times 6, I get an answer of 6. It stays the same size and stays right where it is. If I do 1 times negative 7, it will stay the same size and exactly where it is. But what happens if I multiply by negative 1? So if I take the same example, my number stays the same size, but the minus sign makes me flip over to the other side and gives us negative 6. In the same way, if I multiply a negative number, negative 7 by negative 1, it stays the same size, but when I multiply it, it's going to flip over to the mirror line to its mirror image at 7. So what happens if I multiply by a negative 2? So let's say I multiply 3 by negative 2. Well, what happens now is my 3 is going to double in size. So my 3 doubled in size becomes 6, and the negative sign flips me over to the other side. So my answer is negative 6. If I multiply by negative 2, by a negative number, let's say negative 1, what happens? Well, my negative 1 is going to double in size, so it's going to become minus 2. Because I'm multiplying by a negative, it's going to flip sides and become 2. What happens for division? Now, if I take a 6 and I divide it by 1, 1 goes into 6 times, so we stay exactly where we are. Now, what happens if I do 6 divided by negative 1? Well, I start at 6, and how many times does 1 go into 6? 6 times, but it's a negative going in, so it's going to be its reflection over to the other side equals negative 6. Now, if I make my divisor bigger, the same idea is going to apply. So if I divide by a negative 2, how many 2's go into 6? Well, my 6 now becomes 3, but I've divided by a negative, so it flips to its mirror image on the other side and gives us an answer of negative 3. So this leads to two shortcut rules for multiplying or dividing a pair, that's 2, directed numbers. If the signs are the same, the answer is positive. If the signs are different, the answer is negative. So let's have a look at some examples. In this first one, I want to work out 2 times negative 3. Well, we just do 2 times 3 as normal, and the answer is 6. And then we check these rules. Remember, a number that doesn't show a little plus means it's positive. So this is a positive times a negative. So my signs are different. So my answer is negative. For this pair of numbers, my signs are different. Remember, that's a positive. So I'm going to multiply first. 9 times 4 is 36. And then I'm going to flip its position because we've got a negative times a positive is a negative. In this third example, for dividing, the same rules apply. It's positive 12 divided by negative 2. 2 goes into 12 6 times, and it's a positive and a negative, so the signs are different, so the answer is negative. For the last one of this kind, we're going to see how many 11s fit into 55, and 5 of them do. So my answer is 5, and it's a negative divided by a positive, so the signs are different, so the answer is negative. Let's look at some more examples. Here I have 2 positives multiplying, so the signs are the same, so my answer is positive, just like before we learnt directed number. So 3 4s is 12. In the next problem, my two signs are the same. 3 times 4 is 12. And because my two signs are the same, my answer is positive. So I don't need to show the little positive 12 in my answer. 15 divided by 5, well, we've done those before, is 3. The signs are the same, so my answer is positive. And the last one here is negative 15 divided by negative 5. Well, 5 goes into 15 3 times. Now the signs are the same, so the answer is positive, so it's 3. And these rules apply to a pair of directed numbers, and in all the examples so far, we've looked at a pair, 1, 2, 1, 2, 1, 2 of directed numbers. So what happens if I've got more than a pair? So in this example, we just deal with a pair at a time. I have a negative times a negative, so the signs are the same, so my answer is going to be positive. So this is equal to 2 times 3, or positive 6. Now I have to do the times by 4, and I have two positives, so the signs are the same, so my answer is positive, is 24. So I can do it each pair at a time. Again, in this next example, we're just going to do a pair at a time, and multiplication and division have equal rights. We work left to right. So here, a negative times a positive, the signs are different, so my answer is negative. So 6 times 4 is 24, and that answer is negative. Now I still have to divide by negative 8. So I look at this pair, 8 goes into 24 3 times, and a negative, the signs are the same, so my answer is positive, so it stays at 3. Now we've been learning about powers and how powers are shortcut multipliers. Let's see how it works here. So negative 3 to the power 2 is equal to negative 3 times negative 3. The brackets show me that I have to look at the negative 3, so it's the negative 3 times itself that gives me my final answer. Now my signs are the same, so my answer is going to be positive, and 3 times 3 is 9. Now negative 3, all raised to the third power, tells me I've got 3 of these, 3 negative 3's, multiplying each other. Again, I can solve this problem by just looking at each pair. The first pair is the same as the one I just did, negative 3 times negative 3, which is 9. But now I have to multiply by the final negative 3. Now 9 times 3 is 27. And a positive and a negative, well, the signs are different, so my answer is negative. If you have a think about this, there's a shortcut. If you have a negative number raised to an even power, the answer is going to be positive. So the opposite is true as well. So if we have a negative number raised to an odd power, we're going to end up with a negative answer. For example, if I have minus 1 and I raise it to the 60th power, 1 times minus 1 times minus 1 times minus 1 times minus 1, and so on and so on. Well, 60 is an even power, and so it turns out that my final answer will be 1, so I end up with a chain of positives. If, on the other hand, I take negative 1 and I raise it to the power 41, so a negative 1 41 times multiplying, I can get 20 pairs of those in, but I'm going to be left with a final multiplier of minus 1. Each of my pairs will come out to a positive, but my final multiplier of minus 1 will flip it to negative 1.